Hello guys, welcome back. Today we'll continue with Kubernetes best security practices on TryHackMe. We've done task 1 up to task 4 and we'll be moving on to task 5. Task 6 has a machine there, so I already deployed it. So by the time we get there, the machine would have started. Today we'll be looking at the best security practices for Kubernetes. With the knowledge gained so far, your understanding of Kubernetes is growing. A more in-depth look at role-based access control and Kubernetes service accounts has allowed for a deeper understanding of cluster access. This task is going to be dedicated to shouting out some other notable Kubernetes security practices, a collection of do's when it comes to Kubernetes security. Without further ado, let's get started. We'll be looking at image scanning first. So we are going to take things back a step. Why do we want Kubernetes in the first place? To deploy our apps, right? Well, those apps are made using images, and the app image will contain everything needed for the app to run on the container. But what else does it contain? Image scanning is one way to find out. Images are generally made up of a series of commands or layers that create directories or users, they copy or run scripts, and install tools or libraries. All of these have security implications. 1. The tools, libraries, and code we use in our app may come from an untrusted source, and this can lead to backdoors in your application code, intentional or otherwise, giving an access to attacker. 2. Official container images are often used as a base image and built upon when making an application. For example, if you are building a web application, you may use the Nginx-based image, or if you are building a database application, you may use any of the Postgres, Nginx, MongoDB, or Redis-based images. These official container images are often considered safe because, well, they are official. However, these official container images can contain vulnerabilities, and they frequently do. Of course, non-official images and outdated images can pose security concerns as well. Because of the above mentioned security implications, it is a best security practice to minimize attack surface in your image by using only the libraries and application needs and using the most lightweight base image for its intended purpose. So if an application does not need a library, you do not have any reason to use it. Now, these security implications are not to be taken lightly, as a vulnerability in your application image could be just what an attacker is looking for. An attacker could exploit this vulnerability and use it to break out the container the application is running in and access the host, wreaking havoc on the cluster and gain access to critical cluster information such as the Kubernetes API authentication stats or tokens. This would be a massive security incident, and this is why image scanning should always be introduced into a CI/CD pipeline as a best security practice. Image scanning tools scan the image being used against a database of vulnerabilities and look for things like hard-coded secrets. With an image scanning step in place, you can rest easy knowing that what is being deployed into your cluster is secure. Upgrading the cluster. So after we've scanned, you may have to upgrade depending on the stage we are on. Keeping up to date is a general best security practice, not one specific to Kubernetes. This is not only specific to Kubernetes, even on our mobile phone, we upgrade our OS, right? Running an old version of Kubernetes come with all the same security concerns. If an attacker finds a cluster running an older version node, they may know a few vulnerabilities that have since been patched. And of course, updating a Kubernetes cluster comes with the same stable versus latest considerations. Stable releases have been thoroughly and fully tested, so they are generally favored from a security perspective. However, The latest version, which will have been internally tested, will include patches for issues in the stable version. Ultimately, as long as you are at least using the stable version, you are following the best Kubernetes security practices. Note, when choosing the version to upgrade to, that is the latest version, for example, you cannot skip minor versions. For example, you cannot upgrade your cluster from version 1.21 directly to 1.23, as you'll be skipping minor version 1.22. So if the latest stable version were to be 1.23, you would have to do 1.21 to 1.22, then 1.22 to 1.23. Upgrading a cluster usually falls to a DevSecOps engineer, or at the very least, the DevSecOps engineer will work alongside a DevOps engineer to ensure that this is done. Due to the nature of versioning, there are constantly new versions being released, and keeping the cluster up to date can become quite a task. Because of this, teams sometimes overlook the upgrade process and fall behind on a few versions. Following best Kubernetes security practices, your team will regularly assign you tickets to get the cluster upgraded. This will usually have to be done in the following order. 1. You update the control plane nodes, upgrading components in the order of etcd, that's the storage, the Kube API server, the Kube controller manager, the Kube scheduler, and the cloud controller manager. 2. If the cluster has additional control plane nodes, we upgrade those. 3. We then upgrade the worker nodes. Then we upgrade clients like kubectl. And finally, we make changes to manifest and resources based on changes in the new version. For example, if some of your resources are using a now depreciated feature, update them to use the replacement. Now, here are some things to consider when upgrading the cluster. More than one worker node can be upgraded at a time. When upgrading a Kubernetes cluster, only internal components are touched. In other words, your apps and workloads should remain untouched and unharmed. However, it is always a good practice to take a backup of important components before the upgrade, just in case. Nodes need to be drained. This way, pods are evicted from the cluster and workloads are unaffected. Upgrading a cluster often comes with downtime. Depending on the importance of workloads being run in the cluster, this may lead to downtime for external services, internal or external, and for this reason, a downtime notification with a maintenance window attached should be sent to the affected parties. Non-root container running. Don't forget we started with image scanning, then we moved to upgrading the cluster. Now we'll be moving to non-root container running. Unless there is an operational need for it, which there almost never is, a container should be run as a non-root user. This is because, like previously covered, your image has vulnerabilities in it, and an attacker gains an access to the container. That means you are making it a lot easier for them to escalate their privileges. So this can be done when defining the image. However, certain specifications in your pod configuration YAML can override this. As a DevSecOps engineer, you will likely be reviewing your fair share of resource configurations. And if you see in the spec under security context, values such as run as user, you have to check the UID just to be sure that the user ID does not have root privileges. Or when you see things like allow privilege escalation, that is true, your alarm bells should be running. You should verify that this is not required, which again it almost never is, and change the pod specification to look more like what we have here. In this case, we have for the security context, we have allow privilege escalation to be false. And for the non-root user, we have run as user. We can see that we have an empty space here. So we are not running the user as root. Fourth one, secure etcd. As you may remember, etcd is Kubernetes key value store where cluster data is kept. You can hear that cluster data is kept, and an attacker hears what gold mine, and they are right. I mean, that's what I'm here really. I need to know what the security challenges are. Changes made in the cluster, such as a pod being deleted, are then reflected in the etcd store. However, it goes both ways. If a change were made in the store, such as a new pod entry, that change will be reflected in the cluster. Imagine now an attacker gaining access to the etcd. Suddenly, they are not so concerned with finding ways to gain API access to the cluster, but they have found a way to bypass the API altogether. So an attacker gaining full access to the etcd is one of the worst things that could happen in a Kubernetes cluster, as it is essentially unlimited access. This brings us to some of the best security practices which should be followed to secure the etcd store. 1. etcd can be isolated from the cluster and run separately. Putting distance between the cluster and the etcd store should the cluster be breached. 2. We put etcd behind a firewall, ensuring it can only be accessed via the API, going through the appropriate API request stages. 3. We encrypt all etcd data. This would be done using either built-in encryption at rest mechanisms or an encryption provider. This way, if an attacker was able to access the etcd, they wouldn't be able to decipher the contents. Now we are going to answer the questions below. Which best security practice should be introduced to the CI/CD pipeline? We have image scanning, as we first said. What should be set as false in configuration to ensure a container cannot have its privileges escalated? That's allow privilege escalation. To ensure the security of the storage, it should be isolated behind a firewall and encrypted. And how many cluster upgrades would you have to do to go from version 1.21 to 1.25? So 1.21 to 1.22, 1.22 to 1.23, 1.23 to 1.24, and 1.24 to 1.25. So we are going through 4 cluster upgrades. With that, we've come to the end of best security practices. I'm looking at a practical part to this. So I'm going to show split view, and I can see that my machine has started running on the other side. Okay, I hope the network is on my side. So here is what we have to do. It is another week for you at Kubernetes Laboratories, and your DevSecOps journey continues with another stand-up meeting. Everyone is dished out a ticket, including you, and the ticket you have been assigned to is to review RBAC configuration for test chambers checker. Okay, it sounds like you are going to be able to put your Kubernetes best security practices knowledge to use. Let's first boot up the machine by clicking the green Start Machine button. The machine will start in split screen view, and in case the VM is not visible, you are going to use the blue Show Split View button at the top of the page. That's exactly what I did, and I'm wondering why my machine is not coming up. Let me just terminate and start again. Yeah, because it's really surprising that it's not coming up. Okay, let's start again. And while we wait for the machine to boot, we're going to see what we are asked to do. So now we're expected to fire up the machine and run the command. We are going to be using Minikube, and that's because this is a practicing environment. So once the cluster has started up, we are going to look at the test chamber namespace. So what we are expected to do is we are supposed to review the role-based access control configuration for test chambers checker. So we are going to take a look at the test chamber namespace, and this is where we are going to be reviewing the configuration. We've been provided with a command to see what is running in this namespace. We're supposed to use this to get the pods. We start minikube. We're going to provide us the environment. Then we are going to use this command to get the pods. Okay. So once we view all the pods, we've been told what the ticket said. The ticket details the purpose of this checker, and it is simply to list the status of the pods in the test chambers and log it. And we are going to be getting information about the pod using the command. Okay. I'm expecting this to show. I don't know why it's taking so long. Okay, let's see. We're supposed to look at it and see if we can find any red flags. And we've been told that we'll find it in the first few lines. Okay. I need this to fire up and we can move on with the practical aspects. The internet is not on my side today. Hmm. So since this is not coming up, in another video, we'll be taking it extensively, just majorly for this purpose. Thank you so much for listening.